morning, class. This is day 35 of Coronachem. This is the homework I gave you on Friday. I asked you to convert how many femtometers squared are in 1 mile squared. And we should know by this point that 1 meter contains 10 to the 15 femtometers. I asked you to memorize at the beginning of the year all the prefixes and the multiplier or demultiplier effect that they have. So you should know kilo is times 1,000, mega is times 1,000,000, giga is times 1,000,000,000. Then it goes tera, and then finally peta. So giga is times a billion, tera is times 1,000,000,000,000, and peta is times a quadrillion, times 10 to the 15. If you go the other way, if you want to make something 1,000 times smaller, you're going to say milli. If you want to make something 1,000,000 times smaller, you say micro. 1,000,000,000 times smaller is nano. 1,000,000,000,000 times smaller is pico. And then a 10 to the negative 15, or quadrillion times smaller, is femto. Okay, and everything below, the bigger ones, the multipliers are all uppercase, except for some reason they made kilo lowercase, and everything below that is also lowercase. And the demultipliers they're all lowercase. So go figure. Now the question was, convert 1 mile to femtometers squared. 1 mile squared to femtometers squared. The easiest way to do this is to find out how much a linear mile is in femtometers. So that's what I did. I used all the known conversion factors that by now you should be starting to recognize as fairly familiar. You should know there's 5,280 feet in a mile. So the miles will cancel. And you always arrange the conversion factors so that the thing you're trying to cancel out is opposite. So I could have written 1 mile per 5,280 feet, but that would put miles in the numerator, so it would put it upside down. You need to put it the other way so that mile in the numerator here can cancel with mile in the denominator in the conversion factor. The next conversion factor, you're going to have an answer in feet, but you could do this in all the steps one after another, and then cancel everything that you don't want until you get the final answer, and then you multiply all the numbers together to get the final answer. Now I want to convert feet to inches, so I'm going to put feet on the bottom, and I know there's 12 inches per foot, allows me to cancel feet. There's 2.54 centimeters per inch, which allows me to cancel inches, and there's 1 meter per 100 centimeters. I know we're going backwards here for a second, but it's because I know the conversion factor from meters to femtometers. I don't necessarily, well, I could figure it out if I just think for it briefly, but it's better to play it safe and know the things that you're familiar with, especially if you're writing an exam. You don't want to be making a silly mistake like that could cost you marks. Okay, so then at the end you convert it to femtometers by canceling the meters as well, and what you get is 1.609 times 10 to the 18 femtometers. That's the length of one side. But we know that we're calculating the area of a mile squared, which I forgot to put there. Well, but I said I was going to do it linearly, so it's okay. I'm not going to put the mile squared till later. I'm doing that step here. So one side, the length of one side times the width, if it's a square, is the same as the length squared, because both sides are the same length, so length equals width in this case, because if it's a square. So we can say L squared is equal to this number that we just figured out, and that's going to equal the area. So the area turns out to be 2.58 times 10 to the 36 femtometers squared. There's another question I'd like you to work on using the two equations that I taught. Well, no, I don't actually use two equations. I used to use the rate equation in this one. and then I ask you to find the volume. Okay, I'll do that one with you, because I've asked this one to all my classes in high school, because it's a good exercise that teaches you how to make conversion factors. I have other videos posted where I do this calculation or something similar to it, but let's do it since we're doing our review now. Let's do it together. Guys, this is a big opportunity for you to review all the material that you may have found difficult at the beginning of the year. The second time around, you're going to find it easier. So don't waste these opportunities. I've been noticing the video numbers are dropping off a little bit. I think some of you guys are just sort of throwing in the towel. It's good to see when people take charge of their own education, and I encourage you to keep tuning in. Okay, so here's the question I want to ask. So, the speed of light is 2.99792 458 times 10 to the 8 meters per second. How much how many femtometers cubed are in 1 light year cubed? And it's a number that is so staggeringly large that it may strain the capacity of your calculator. Well, your calculator can do it. It's just that you're going to be at the limits of what the memory can input. Your calculator can't put in a number bigger than 9.79 times 10 to the 99 power. So if you try to do Google, that's the capacity of your calculator. The calculator cannot enter the number Google. It can do Google minus 1. Actually, more than minus 1, because there's only 8 numbers after the decimal. So Google minus whatever the number times 10 to the power of 92 is. So first of all, a strategy to solve this problem, I find the easiest strategy to use to solve this problem is to find out, knowing the speed of light, how far a beam of light travels in 1 year. Convert that, rate times time equals distance. Okay, so that's what you're going to do first. Rate times time equals distance. What is a light year? It's the distance traveled by a beam of light in 1 year. It's a very long distance. Light coming from the surface of the sun takes 8 minutes to get to the surface of the earth. And it travels that 93 million miles in 8 minutes. It's a huge space, but it's still, light will do it in 8 minutes. But imagine the closest star, 4.3 years. So you can see what the distances in the cosmos are. They're staggeringly large. They beggar the imagination. In fact, only 100 years ago, scientists thought that the entire universe was what we call our galaxy now. And then as telescopes got better, they started noticing that some of the smudgy looking stars were actually entire galaxies with billions of stars in them. So then they realized, wow, the universe is a lot bigger than we think. The Andromeda Galaxy, for instance, one of the galaxies that's closest to us, is 2 million light years away. 2 million years. Light takes 2 million years to get here. So what we see from the Andromeda Galaxy is the way the galaxy looked 2 million years ago. If they were to look at us from the Andromeda Galaxy, they wouldn't see what we're doing now. They would see what we were doing 2 million years ago. Anyway, the speed of light then is 2.99792 458 times 10 to the 8 meters per second times the time, which is 300. Well, we know how much a year is, but we want to convert that into seconds. So we're going to start off with 365 days in 1 year times 24 hours in a day times times 3,600 seconds in an hour. If I have to explain that to you, you haven't been paying attention in class. All right, so the days cancel, the hours cancel. Well, a light year, I shouldn't have put a year because the light year is not there to cancel, but we're saying it's 365. A light year is 365.25 days. Okay, so that cancels it. Now we get this a year in seconds. That's the speed in meters per second, so the seconds are going to also cancel, and then we'll have our distance in meters. What we get is 9.46073 047 times 10 to the 15 meters. That's how far a beam of light travels in 1 year. Now let's convert that to femtometers. We know there's 10 to the 15 femtometers in 1 meter, so that number turns into 9.46, etc. I'm not going to rewrite all the decimals, you see them there, times 10 to the 30 femtometers. Now, we haven't found the volume of the cube in femtometers. We've only found the length of one edge of that cube. But as you recall, the volume of a cube is equal to length times width times height. But because we have a cube, length equals width and it equals height, so you can also say length cubed. So the volume of our cube is L to the power of 3, which equals 9.46, etc., times 10 to the 30 femtometers raised to the power of 3. What you get as an answer is 8.4667, 86665 times 10 to the power of 92 femtometers cubed. I guarantee you that's probably the biggest number you're ever going to use in a scientific calculation. Okay, so I'll just do a couple more. One more example from the text. No, those ones are too easy. Actually, I'm going to do. No, this question is too advanced for you. I'll do number 24. Number 124. Okay, what does it say for 124? It says use appropriate metric prefixes to write the following measurements without use of exponents. Without use of exponents. Oh, they're putting limits on us. Okay. It's getting hot. It was 80 degrees in the house yesterday, so I turned on the AC. It's starting to feel like 80 degrees again, even though the AC is running, so I think my AC needs to get looked at. Okay. So 124. The first question from the textbook. Don't worry about it. I'll copy the question. So 6.35 times 10 to the negative 2 liters, and I want you to convert it to milliliters. So the conversion factor from milli to liters means there's 1,000 milliliters in 1 liter. So you're going to say you want to cancel liters, so you're going to say 1,000 milliliters per 1 liter, and what you're going to get is 10 to the 3 times 10 to the 2. Wait a minute. What did they say in there? Without use of exponents. That doesn't mean we can't use exponents to solve it. They just want the answer not to be in exponents. So I'm going to rewrite that as an exponent. I'm going to say 10 to the 3 milliliters per liter, because it makes it so much easier to solve this. 10 to the minus 2, okay, the liters will cancel. The 10 to the minus 2, when you multiply by 10 to the positive 3, remember you add the exponents, so you get 10 to the positive 1. So your answer is going to be 6.35 times 10 to the positive 1 milliliters. Well, what's 10 to the positive 1? It's 10. 10 to the power of 1 is 10. What's 6.35 times 10? The answer is 63.5 milliliters. You'll notice no calculators were harmed in the making of this film. In fact, they weren't even used. 6.5 times 10 to the minus 6 seconds times 1. What do they want us to do it? Turn it into? It's always good to see what the question is asking you. They want you to turn it into microseconds. Well, micro means millionth, so that means there's a million microseconds per 1 second. So what we're trying to get rid of is seconds. So we're going to put 10 to the 6 microseconds in 1 second. That allows us to get rid of seconds. 10 to the minus 6 times 10 to the positive 6 gives you 10 to the 0. So what you're really doing is 6.5 times 10 to the minus 6 times 10 to the positive 6, which equals 6.5 times 10 to the 0, which is like saying 1. 10 to anything to the power of 0 is 1. 6.5 times 1, I hope you realize, equals 6.5 microseconds. There's your final answer. Again, calculator not needed if you know the power of exponents. By using powers of 10, it makes it easy to just look at this, minus 6 plus 6, that's 0, and that's where you get your 1 over here. Next one. Part C. C, they have 9.5 times 10 to the negative 4 meters times, they want you to turn it into millimeters. So there's 1,000 millimeters in a meter. So 1,000 millimeters in 1 meter. Let's rewrite this so we can see what exponent is. 1,000 is 10 to the power of 3. So you have 10 to the 3 millimeters in 1 meter. Let's rewrite the part we're working on. So that allows us to cancel meters. 10 to the minus 4 times 10 to the positive 3 is going to give you 10 to the minus 1. So your answer is going to be 9.5 times 10 to the minus 1 millimeters. But they said they don't want exponents in the answer. What's 10 to the minus 1? It's 1/10. So 9.5 times 1 over 10 gives you 9.5 over 10, which is 0.95 millimeters. Final answer. Again, the less you need to rely on your calculator, the more you've built up the way of thinking that allows you to speed up when you do math. What gets a lot of kids in the final exams is they don't feel comfortable doing the math. They don't have the confidence because they haven't done it. I don't know what's going on in their elementary schools, folks. I don't know what you guys are doing. You're writing crosswords all day. I don't know. Anyway, you're not getting that confidence you need from doing basic arithmetic by rote. There's a bad word, rote. You say rote, people throw up their hands and scream and run out of the room. But maybe they should bring some of that back because the kids aren't getting enough exposure to it. So when you know your times table like that, when you know how to do simple multiplications, additions, subtractions, there's no reason for you to reach for a calculator. I'm not trying to make you feel guilty. I'm just telling you the truth. There's no reason for you to be reaching for a calculator if you're dealing with 1-digit numbers. You got to know those in your head. 7 plus 7, 14. 7 plus 6, 13. Stuff like that. It's got to come to you like that. You shouldn't be looking and then reaching for a calculator. That's no good. If that's happened to you, you haven't been taught properly. It might not even be your fault. If it is your fault, do something about it. Study. Okay? Because if you're in an exam and you're reaching for your calculator to do single-digit additions and subtractions, you're already dead in the water. You're already in trouble because now you can't free your mind to think about the higher levels of thinking that have to go on to do conversion factors and problem solving. That stuff should be automatic. 124D. Yeah. So 4.23 times 10 to the negative 9 meters cubed, and they want you to convert it into millimeters. All right, so we know there's 1,000 millimeters in 1 meter cubed, in 1 meter. But we're dealing with volume, so we're going to have to raise the whole conversion factor to the power of 3. And that might scare you a little bit, but let's just keep our heads screwed on right, and we'll see that it's not that hard. So 10 to the negative 9 meters cubed. What's another way of saying 1,000? It's 10 to the 3. But that 10 to the 3 is also being raised to the power of 3, so it becomes 10 to the 9. So this is 10 to the 9 millimeters cubed. 1 raised to the power of 3 is still 1, and meters raised to the power of 3 is meters cubed. That allows you to cancel the meters. Now, when you multiply 10 to the negative 9 by 10 to the positive 9, you get 10 to the 0. So the answer ends up being 4.23 times 10 to the power of 0, and the answer is millimeters cubed. So that's 1. So the answer, your final answer is 4.23 times 1, and that means your final answer is 4.23 millimeters cubed. I'm showing you every single step. I'm belaboring the process, but hopefully you can skip some of the easy parts. Like when you see that 10 to the minus 9 times 10 to the minus 9 times 10 to the positive 9 gives you 10 to the 0, and you know that 10 to the 0 is equal to 1, and you know that 1 times anything gives you a number, just go straight to giving the answer. I'm just showing you the whole process so you don't say, sir, where are you getting these answers from? Okay? So skip as many steps as you're comfortable with, but always keep in mind that the teacher may also want to see what your reasoning process is. So at some point you might also have to put it in these steps that you see are trivial, but are necessary to prove to the teacher that you know what you're talking about. (124e). It's 12.5 times 10 to the negative 8 kilograms, and they want you to convert it into micrograms. Well, I'll do that in 2 stages because I don't know the conversion factor from kilograms to micrograms. I know the conversion factor from grams to micrograms, so let's get the thing to grams first, and then we'll convert it to micrograms. So I know that there are 1,000 grams in a kilogram, so times 1,000 grams per 1 kilogram, and 10 to the 6 micrograms per 1 gram. Now, I can rewrite this as 10 to the 3. I'm not going to rewrite the whole thing. I'm just going to say 10 to the 3 right off the bat. So 10 to the 3 times 10 to the 6 gives you 10 to the 9. But 10 to the 9 times 10 to the minus 8 gives you 10 to the positive 1. So your answer is going to be 12.5 times 10 to the 1. And look what cancels. Kilograms cancels, grams cancel. Your final answer is in micrograms. They don't want scientific notation in the answer, so 12.5 times 10 to the power of 1 is like saying 12.5 times 10, so it's 125 micrograms as the final answer. F. It's not your mark, it's the next question. 3.5 times 10 to the negative 10 grams times, they want us to turn it into picograms. Picograms is 10 to the 12, right? There's 10 to the 12 picograms in a gram, or you can say 1 picogram is 10 to the negative 12 grams. I like to keep them positive. So 10 to the 12 picograms per gram, and grams cancel. 10 to the negative 10 times 10 to the positive 12 gives you 10 to the power of 2. So 3.5 times 10 to the power of 2 picograms. And then 10 to the power of 2 is 100. 100 times 3.5 gives you 350 picograms. 350 picograms. Last one. I'm going to make more room. (124g), 6.54 times 10 to the 9 femtoseconds and they want you to convert it into microseconds. I don't know the conversion factor from femto to micro, so I'm going to go back to seconds, and then from seconds back to microseconds. So I know it's a bit roundabout, but I find it's the safest way to do it if you're not sure. So 1 second per 10 to the 15 femtoseconds. That allows me to convert to get rid of femtoseconds. And then go back to 10 to the 6 microseconds per 1 second allows me to cancel seconds. And the answer I'm going to get is, look, I have 10 to the 9, 10 to the 6, that gives you 10 to the 15, positive. And then 10 to the 15 over 10 to the 15 is 1. So your answer is 6.54 times 1, or 6.54 microseconds. That's the only unit that doesn't cancel. There's your final answer. All right, so you see that I didn't use a calculator at all because I just know what the numbers are that you can convert into power. So just a little refresher. 10 to the power 3 is 1,000. 10 to the power 6 is 1,000,000. 10 to the power of 9 is 1,000,000,000. So basically, the trick is 10 raised to whatever power is like 1 with the same number of zeros as the 10 is raised to the power. All right? So if you have 10 to the 12, it means a 1 with 12 zeros after it. So rather than write out 1 trillion, you're better off just saying 10 to the 12. Okay? And that's where that comes from. That's the power of exponents. It makes things a lot easier. Let's, why don't you guys try 125. It's got 3 questions in it.
Yeah, I'll just show it to you.
You should be able to see it clearly enough. Number 125. Okay. And tomorrow we'll look at it together.